In this example, we're going to evaluate integral of e to the power 3 theta cosine of theta d theta, and we'll apply integration by parts rule. Let me write down the integration by parts formula. Integral of u dv equals u v minus integral v du. Okay, so we need to decide what's going to be u, and that's what's going to be dv for this example. Well, let's try. Remember, it's worth just to try something and see if it's going to work or not. Let's try to assign e to the power 3 theta to u, so u equals e to the power 3 theta, and then dv, okay, so that part is u, and then dv has to be then cosine theta d theta dv. From here we have to obtain du by finding derivative of the right hand side, and from dv we'll have to obtain v by integrating the right hand side. So integral of u to the power 3 theta, we have to use chain rule here, right, because it's a composition of functions. The outer function, like the big picture, is u to a power, while u to the power, when we find derivative of that, it's the same thing, right? It's u to the same power, 3 theta. But then we also have to multiply it by the derivative of the inner function, so derivative of 3 theta. Derivative of 3 theta is just 3 d theta. So I'm going to rewrite, and I'll get 3 e to the power 3 theta d theta. So that's du. Now to find v, let's obtain antiderivative of cosine. Antiderivative of cosine is sine of theta. Okay, so now we have all the pieces to continue with the formula. I'll continue here. Equals. Now the right hand side, u times v. U is e to the power 3 theta. V is sine of theta, minus, that's u, this is v, minus integral v. V is sine theta, and then du is right here, times 3 e to the power 3 theta d theta. Now let's see what we end up with. That's I'll just make notes for myself. That was v, and that part is du. I'm gonna rewrite so I have this constant within the integral. I'm gonna put it in the front, and then I'll take a look at what we got. 3 theta sine theta minus 3 integral, so sine theta e to the power 3 theta d theta. Now let's think. So our next goal is to technically integrate or evaluate this integral, and a lot of times we want to ask ourselves if things got any better with the original substitution. Well, as we kind of like investigate this integral, look at it, we notice that that integral compared to our original one is almost the same, right? So we still have trig function, we still have e to the power 3 theta, so it's not like it's looking better, it's looking worse than it used to be. It's about the same. So, well, the first thing that can come to our mind is that maybe our choice of substitution here was not a good choice. Let's maybe like without writing any extra notes, let's just think what would happen if we switched the order. So if u was cosine, and then dv was e to the power 3 theta d theta, would make any difference? Well, if u is cosine, its derivative is going to be a negative sine, which means that trig function is not going to go away, right? And then here, if dv is e to the power 3 theta, its antiderivative v would be same thing, e to the power 3 theta. So it means that neither one of those two, like trig function and e to the power, would not go away, even if we switched the order. Well, then, what do we do? Now, so long story short, we can just, we can keep this kind of choice of u and dv. But how do we proceed from here? Well, we can try substitution, we can try integration by parts again, right? Because there is no other method we can really apply here. But what's the point here? What's the point? Because now we realize that as we continue with integration by parts, we will not be able to get rid of either trig function. They will just alternate between sine and cosine, right? We won't be able to get rid of them completely, and we won't be able to get rid of e with its power. So is there a point in just continuing with this process? Well, there is a point. We will continue, we'll apply integration by parts again, and our goal will be the following. Our goal will be to get to the point where integral looks exactly like the original one. And you'll see why. So let's keep going. So integration by parts one more time. I'm going to change the color. This time, well, I'll just keep it consistent with my original substitution here. So I will let u be equal e to the power 3 theta, and dv is going to be this time sine theta d theta, like that. That means that du is derivative is, and we already practiced that, right? It's over here, so it's 3 e to the power 3 theta d theta, and then v is negative cosine theta, right? So let's write what we're gonna have. Okay, I'll continue here. Now first I have to rewrite this first expression, e to the power 3 theta sine theta minus 3, and now times. Okay, so I have to be careful here because this one integral right now, since I'm applying integration by parts, is the left hand side of my formula, right? So this integral I'm going to replace by the right hand side of the formula, so it means that by this difference. And since I'm replacing it by difference, well, I'm going to keep it inside the brackets. And it's important to use brackets here or parentheses, not to lose any signs or not to mess up the coefficients. So applying the formula, according to the formula, I have to do u times v. So u is e to the power 3 theta minus, times, and that's just u. That's u times v times negative cosine theta, and then minus, I keep going with the formula, integral of v du. So that's negative cosine theta du times 3 e to the power 3 theta d theta, like that, brackets. I'm gonna make notes for myself here. So that was u v du, right? So make sure that you can see and find all the pieces of that formula. Well, I'll need to simplify, so there are a few negative signs that I want to be careful with. What I'll do, first I'll simplify everything inside the brackets, e to the power 3 theta sine theta minus 3, and now inside the brackets I have this negative, so it's negative e 3 theta cosine theta, and then this negative I can put in front of the integral, but then I have another minus, so it's going to be plus integral cosine theta. Oh, and then I also have that constant 3, right? So I'm also going to put that in front. 3 cosine theta e to the power 3 theta d theta. Like that. Okay. And then I'm still simplifying. What I'll do at last here to simplify this, I will distribute that negative 3. I will distribute it. That's what I'll end up with. E to the power 3 theta sine theta plus 3, negative times negative, positive, plus 3 e to the power 3 theta cosine theta, and then negative 3 times positive 3, that's negative 9, so minus 9 integral cosine theta e to the power 3 theta d theta. Okay, now I'm going to look at what I have here and think what to do next. So I have this result within with another integral, right? And within that integral I can still see a trig function, and I can still see that exponential function e to the power. And we already talked about how we're not gonna get rid of those two, right? No matter how long we're gonna proceed with this. However, what I can notice now is that this integral is exactly the same as the one I started with, or well, the one that we needed to evaluate. So let's compare this integral with where we started. It's over here. So notice how it has e to the power 3 theta and cosine and then d theta. It's written in different order, so here I have e first and then cosine. In this case it's cosine and then e, but I can easily switch the order, right? Well, that's the key step, or that's the key step where I'm gonna stop integrating and I'll do the following. So to make sense out of all that, I will rewrite the original integral. I want them to be kind of like closer to each other, and then I said equals, well, and I write out where we end up with, right? Because this is just like a chain of equalities. We have equal signs everywhere, so it means that if I trace back, well, I'll go back to my original expression. So it means that I can take my original integral and set it equal to whatever we ended up with. So I'm rewriting it. Minus 9 integral cosine theta e 3 theta d theta. And here I'm going to point out that those two are the same integrals. Same integrals. So this is how we're going to finish this. Since they're the same integrals, it means that what I can do, I can add 9 integral cosine theta e to the power 3 theta d theta to both sides. Okay, I'm writing this. Plus 9 integral cosine theta e to the power 3 theta d theta on the right hand side, and then plus 9 integral cosine theta e to the power 3 theta. I can add that to both sides. It means that it's gone from the right hand side, but my left hand side is now the following. Well, it's 1 integral like that plus 9 more integrals like that, so I have a total of 10. So 10 integral cosine, and I guess I have to choose which order I keep. You know what, I'm gonna keep the original order, just so that we will end up with the exact integral we started. So I'll put e to the power 3 theta cosine theta d theta, and then what's left on the right hand side is just the sum of those two expressions. E to the power 3 theta sine theta plus 3e 3 theta cosine theta. By the way, they're not like terms, right? they're different expressions, so I just have to keep them separately. And what is the last step? We're pretty much done. So remember, I had to evaluate this integral. I needed to know what it equals to. Well, I'm gonna find out what it equals to if I just divide by 10 on both sides. So in other words, once I get it by itself and get rid of that 10, coefficient 10, then I'll know what it equals to. So the last step is to divide by 10. And on the right hand side, I think I'll divide each term by 10. I could have divided like the whole thing by 10, but I'll just divide each. So 10 cancels. I have integral e to the power 3 theta cosine theta d theta equals, I'll say 1 over 10 e to the power 3 theta sine theta plus 3 over 10 e to the power 3 theta cosine theta. And that's what that integral equals to. There's some options here for how you can simplify it, not simplify it, but maybe manipulate this expression a little bit further. You can factor out maybe like 1 over 10 times e to the power 3 theta in, write in that form, in factored form, or you can just leave it like that. I'm just leaving this in this form. And yeah, that's going to be the answer. So what can we see from this example? Well, we can see that the following. If it happens that you're evaluating a function that consists of two other functions and neither differentiation or integration allow you to get rid of them completely, then this is something you can do. You can repeat integration by parts a few times. Well, here we only had to do it twice, right? You could come across examples where you have to do it more than twice. But you keep going and you keep integrating by parts until you end up with an integral that looks exactly the same as the one you started with. And once you're at that point, what you have to do, you just have to move that integral, well, with its coefficient, most likely it will have some kind of coefficient there, move that integral with its coefficient to the other side, so combine it together with the original original integral. And after doing that, solve for that integral, get it by itself, get rid of the coefficient, and you're gonna obtain the result of that integration. So that's what we get in this example.